All right, let's take it away.
So, hello everyone. Today we'll be presenting our project in Oceanhackweek 2021. The title of our project is CMIP6 Analysis Ready Data Workflow, turning big climate projection data into useful inputs for modeling or analysis. We had a bunch of people joining us from across the world. We had Andrew, Ibuki, and Rachel from North America, Denisse from Australia, Noraini from Malaysia, and Dhruv, Suman, Aditi, and myself from India. Our mentors were Thomas, Paige, and Julius, and we are thankful for their constant support. So coming back to the project, the Climate Model Intercomparison Project Phase 6, CMIP6, is basically a collection of global climate models and is a foundation of global climate projections. As we know, climate change is a real issue, and the future scenarios from CMIP6 help us quantify it. It helps the society better understand the choices we must make, and it helps the policymakers to make the best policies which will improve conditions for our future generations. However, there are often barriers for new users or specific disciplines. These initial barriers could be in terms of big data, file format, or technical terminology. Here, we aim to provide an example workflow using the new CMIP6 Preprocessing and region mask package, which could be very useful for a new user. So a new user could just go through the example to fetch the data and to make it into an analysis-ready format. We hope this example could be added to the new to the CMIP6 Preprocessing documentation or to the Pangeo gallery. I request now Suman to now take over.
So in this workflow, the first challenge could be accessing the data. So earlier, some researchers were like downloads all the data from the store. So it could be not that feasible. So we come up with this optimized way where we use some packages like intake and Pangeo modules, which helped us to go at the data cloud and compute our analysis there. So we don't need to download any data from there now. So this is how we can grab the data, and we can view it as a pandas data frame. So now I was working with Andrew and Shikha on this accessing data part, and we come up with this function where we can analyze what unique models are there with our requirements. So this is a model. This is a function that allows us to do so. Now, the next part comes after accessing the data should be the pre-processing part. As we know that all models uses some different conventions, different indexes. So that could be better if we can merge all those indexes into a single index and change their terminologies for just to escape from writing a lot of if-else statements. So this pre-processing module in CMIP6 Pangeo model, it allows us to do so with merging all those indexes. Now the next part comes where we also added some matrices that allows us to compute averages over all the latitude and longitudes. And now there is a quick example also that how we can go through the loop over several modules, over several models. These are the plots that you can see in this plot. And the next thing that we would like to do is combining the data. So this is a module in CMIP6 preprocessing package where we just combine the data which has with similar variable IDs with different ensembles, and this is how we combine using this module. And then Andrew visualize some multi-model ensembles, and I think he would like to go through brief into this in his US time zone. So yeah, this is where we visualize some ensemble models. So I'll handle it over Denisse.
Hello, everyone. So what we did in our group was to focus on actually applying mask to our data array. So to create a mask, we actually have a shapefile. In this case, we're using the meso regions that cover the Southern Ocean. We loaded that using the GeoPandas package, and we created the mask using the region mask package that is available as a Python library. So basically here, we just corrected a little bit longitude and latitude. So the longitude will match in both the data set and our shapefiles. Then we created the mask, as we can see, and they created the mask. Basically, we just have a Boolean mask. So it's one only when the region inside the region and it's zeros outside the region. Then we apply the mask, basically just by multiplying the mask to the actual data array. So you can see that just below applying mask. And that allows us to just get the data that we need for that particular region.
6 minutes, Denisse.
Finally, we just plotted the data so you can see that there are the different regions, and this is just showing sea surface temperature. The next step will be to actually perform the zonal statistics, which I presume will be straightforward now that we have the mask working. And that's it from me. Thank you very much.